When I heard about the possibility of a terrorist attack knocking out the United States power grid with an electromagnetic pulse, I began to wonder, how can electronic devices be protected from this event? In my experiment, I was trying to prove my hypothesis. If an EMP occurs, conductive materials and their connection to earth ground will weaken the effects of the pulse. My first problem was figuring out how to create an EMP. I ended up taking two 8.8 microhenry inductors and used an impulse generator to create a 500 microsecond pulse with a peak voltage of 710 volts and a current of 1,530 amps. To show the effects of the magnetic fields of an EMP, I generated an EMP through crushed ferrite. To measure the strength of the EMP, a 1 megaohm resistor was used as a sensor. The voltage across the resistor was measured with an oscilloscope. The control group for this experiment was a cardboard divider. When the EMP was triggered with this divider, 16.9 volts were developed across the sensor. Then I tested three other conductive materials, an anti-static bag, mu metal, and copper. We tried multiple combinations of these materials to measure their attenuating performance. As you can see from this Pareto, the materials work better when they are grounded. However, the mu metal and the anti-static bag weren't as effective as grounded copper. An EMP from a nuclear blast has the potential to produce 6,000 damaging volts across a common smartphone. My results show that a grounded copper sheet would reduce this EMP field strength by a factor of 134 times to only 44 volts. So if you want to keep using your electronics after an EMP occurs, I recommend enclosing them in grounded copper.